Hey everyone, so today we are going to learn how to divide polynomials. So before we look at the rule that we're going to talk about today, let's discover why it works. So we have 2 to the 6th power. Remember, that's 2 times itself 6 times. So that gives us 64. Then we have 2 squared, which is 2 times 2. That gives us 4. And then 2 to the 4th power. Remember, that's not 2 times 4. That's 2 multiplied to itself 4 times, which gives us 16. Okay, so we have 64, 4, and 16. So now let's take a look. What is 64 divided by 4? How many times does 4 go into 64? And the answer there is 16. So in our little division here, we have the same answers that we got over here. So we know that 64 is the same as 2 to the 6th. So I'm going to just rewrite this, but I'm going to rewrite it using those exponents. So 2 to the 6th. Now 4 is the same as 2 squared. And 16 is the same as 2 to the 4th. Now what happened? Take a look at the exponents. What's happening with these exponents here? We have a 6, we have a 2, and we have a 4. Hopefully you noticed that we subtracted the exponents. So we had the same base. We're able to subtract the exponents here to get our answer. Now the reason why that works is I'm going to rewrite this but in expanded form. So 2 to the 6th power and 2 squared. I'm going to just rewrite it over here. We have 2 times 2 times 2 times 2 times 2 times 2, right? 6 times. And then 2 squared, 2 times 2. So we're dividing 2 to the 6th divided by 2 squared. Now, we're able to cancel out some of these 2's. So like these 2's can cancel out, and these 2 can cancel out. And what are we left with? 1, 2, 3, 4, 2 to the 4th. So that subtraction rule is just a shortcut for not having to write this out in expanded form and cancel anything out. So I want you guys to notice we subtracted the exponents here. So we're going to take a look at that rule a little more in the next slide. So the quotient rule is when dividing monomials that contain the same base, so remember they were both 2's, we subtract the exponent and keep the base. So please keep that in mind. We did not do anything with these 2's. It stayed a 2. We didn't subtract them. We didn't divide them. The bases stayed the same and the exponents changed. That's the only thing. Okay, so here's our rule. If we have x to the a power divided by x to the b power, so we have the same base, we're going to keep the base the same and subtract. So the answer would give us x to the a minus b. So let's take a look at another example. So let's multiply this. 25x squared times 2x, and I'm going to put a little 1 there because that has an invisible exponent of 1. Let's multiply the coefficients. That gives us 50. 50. And then we're going to add the exponents here just like we've been doing in the past. 2 plus 1 gives us 3. Now, the same way multiplication and division are inverse, right? They undo each other. So I want to take a look at if we divided this by 25x squared, we would get 2x, and vice versa. So if you take 50x to the 3rd and you divide it by 2x, you would end up with 25x squared. So this is what I'm talking about. We have 50x to the 3rd divided by 2x, and we get that original monomial that we multiplied by, which is 25x squared. So now if you notice, 50 and 2, when we divide that, what do we get? 25. So we have to divide those coefficients. Now, the exponents, we have a 3 here, and we had that invisible 1, and we're going to subtract these. That's how we get the 2 right here. So the rule when we have monomials that have coefficients is when dividing monomials, we divide the coefficients and subtract the exponents of like variable bases. So they have to have the same variable. If this was an x and this was a y, we could not apply that rule. They have to have the same variable in order to subtract those exponents. So let's take a look at another example. Simplify the following: 24y to the 10th and 6y squared. So we have our coefficients. I'm going to look at those first. 24 divided by 6. 6 goes into 24 4 times. So all we did was divide those coefficients. And then we have to subtract our exponents here. 10 minus 2, that's a 10, gives us 8. So that is now our new exponent for y. So that's y to the 8th power. So we divided our coefficients, the numbers in front, and then we subtracted our exponents because they have that same variable base. And that's it. So let's take a look at an example where we're going to be taking a polynomial and we're going to we're going to divide it by a monomial. So simplify the following: 16x to the third minus 8x squared plus 4x. We're going to divide this whole thing by 4x. So I know that it looks different than what we just did, but basically we're going to just divide 3 different times. So the key for this is separate, then divide. So I'm going to separate this trinomial into 3 fractions, and you'll see what I mean. So we're going to take 16x to the third, divide it by 4x. So I just took that first term, dividing it by 4x, minus, I'm going to take that second term, 8x squared, divided by 4x. I'm going to take that third term, so plus 4x divided by 4x. All I did was take each one of these terms and separately I'm going to divide it by 4x. So same rules apply. I'm going to just switch to my red pen. 16 divided by 4, that gives us 4. So divide your coefficients, subtract your exponents, same thing. 3 minus 1 gives us 2, so this becomes x squared. I'm going to just bring down that minus sign. 8 divided by 4 gives us 2. That has an exponent of 1. 2 minus 1 gives us 1. And we know that we don't really have to write that 1, and there's that invisible 1. So you don't have to include that. I'm going to just bring down my plus sign. Same thing here. Divide your coefficients. You get 1. And these, because you're dividing something by itself, these are going to cancel out. So we don't have to put anything here. I'm going to show you why. So we have x divided by x. That's really x to the first divided by x to the first. Now, 1 minus 1 is going to give us x to the 0. Now, anything to the 0 power is just 1. So here, this is really just saying 1 times 1, which we know is 1 here. So we don't need to put anything there. Don't cancel the whole thing out, though, because we still need to write that 1 in, because it's not 0, it's 1. All right, once your answer is written in standard form and everything is simplified, we know we're done. So I'm going to put my answer, I'm going to box it just to show that that is my final answer.